next step. Let's talk about AI. Foundation to every discovery starts with a question. So let us question ourselves too. Why do we need to go beyond the traditional methods of feature extraction? The answer boils down to the fact that traditional CV requires manual feature extraction, which is difficult and prone to errors. There are many advantages of automating the process, which include learning complex features easily, better generalization, and deep learning of features. Let's learn about the basics of neural networks. From here onwards, things might escalate to be a little bit mathematically intensive and esoteric. So, what is a neural network? A neural network is a model in machine learning inspired by the human brain. It is made of interconnected units called neurons. There are various components which make up to be a neural network. These includes neurons, layers, weights and biases, and activation function. We would be learning about all of them in the future. So how does a neural network learns? A neural network learns by propagation of meta input from various hidden layers of neurons, then comparing with the prediction output and the actual result. To understand it further, we take the meta input and make it a linear combination of weights and biases as wx plus b. Then apply the function over it known as activation function, which changes the linearity of the output, and then we feed the new found output into the next layer as input. So now the new question arises is that why we use a activation function before feeding into the next layer. Now let us think that there is no activation function used in the first place. Then in each layer, the resultant input is the linear combination of just the previous input. This limits our prediction to predict only linear functions like ax plus b type of functions and graphs, which is not of much use. We want to increase the range of our prediction. Hence we use activation functions here. Here you can have the essence of what I have said before. Here are a few different functions which are frequently used in as activation functions. Now to compare with the original output and the obtained output, we use something known as the loss function. So what is this loss function? In this loss function helps us to calculate the error or the difference by which we miss the actual output, and this information helps us to tune the weights and biases in the back propagation, which helps us to obtain a much accurate result. Here is the loss function which we generally use in neural networks. It is known as mean square error. This is the mean of the squares of the differences in output obtained and original output, which ensures that the net error or the difference is positive. So the next question which arises is that how do we update the weights and biases? Here we use basic intuition from calculus 1 to do so. The new weight is the difference between the old weight and the first derivative of the loss function with respect to the weight, and multiplied them with eta, which is the learning rate. This method is similarly used to calculate the new bias. The eta value is varied according to the requirement. So here is essentially what we are doing. Let us think that it is the 3D visualization of the loss function, that is z equal to msc. So what are we trying to do is that we are trying to minimize this loss, that is going to the very bottom of this function. So this phenomenon is known as gradient descent. Now since we have learned about neural networks, let us see now how convolutional neural networks are different from normal neural networks. Convolutional neural network or CNN is a specified type of artificial network designed primarily for processing of structured grid data like images and videos. It is the magic which makes the computer visualize and understand things or objects. Components of CNN are slightly different from that of a neural network. There are convolutional layers which help in feature extraction, and then there are pooling layers which are used to extract the most information from these convolutional layers, and finally a fully connected layer. This fully connected layer is used to make predictions from the data. The first step in the process is a convolutional operation, where a matrix moves over the image, performing a dot product operation and hence representing the result as another matrix. Different kernels are used for extraction of different features like edges and all. Here is a visualization of how convolution works. Then we apply something known as pooling. where we move another kernel over the convoluted output and take the maximum value of each zone. This ensures well-defined feature detection of each type and not something in between. Here is a visualization of how max pooling takes place. After doing the convolutional operation and max pooling multiple times, we reduce the dimensionality of the original image and add up many layers representing different features of the image. This forms final something as an input pipeline for the final fully connected layer. The net process what we are doing can be said to be a form of encoder-decoder architecture. Here we encode the features of the image using a convolution operations and pooling. Then we use this encoded information to decode and reconstruct an output which may be restoring the original image or formation of a new image. Net is a type of CNN based on similar architecture and is widely used in medicinal field. Here the encoder captures the image and context via repeated pair of convolution and max pooling, hence reducing the resolution. The decoder performs unsampling and increasing the resolution, highlighting different features of the image. Here is a visualization of how UNet works. Lastly, we are gonna talk about object detection. We employ different types of models based on our requirement for object detection. They are one stage, two stage, and transformer based for various purposes like region classification and object detection and etc. Frequently use an object detection model in robotics known as YOLO, which stands for You Look Only Once, which detects and identifies objects in a video or an image in single step. There is a live usage or implication of YOLO in navigation. As you can see, it is able to identify and differentiate between various objects like car and bus while in motion, so which is very useful in navigation. So here is a quick implementation of the YOLO model which we are talking about. Here it is the YOLO V5 model, and what we are essentially going to do is like we are going to take a video which is like somebody walking through the New York, and we are gonna identify various objects in the video. So here is a sample video of it. So you can see that there are many moving objects here, so many people walking aside, many cars going on, then traffic signals and all, and buildings. So essentially what we are trying to do is that we are going to identify these objects and label them, and then render the video frames with the new labelings over it, and then display it back to the user. So how we are going to do that is that we can see it from the code. So we have imported one new module which is known as torch. So you can just as other models you can just pip install it, and then our OG OpenCV2 we are again using, and then we are loading the model using that torch and the function called torch.hub.load, and then we are using ultralytex YOLO V5 model which is pre-trained, so there is no other thing which we need to do to implement it. So then we are like using the video path as the video playback for that. Then we are like taking each and every frame from that video, and then essentially rendering it with like passing each frame through the model and getting the output, and then using that information to overlay the different labelings over the frame, and then like showing the YOLO V5 video here. So let's see how it works. So what I will do is that I will just python 3 demo.py, I will just write in the terminal and it will just enter. So let's see what it does. Initially when you just run it, it will take a little bit of time because it has to first download the YOLO V5 model and then make all of the processing, so it will take a little bit more time. So let's wait and see. As you can see that everything is working fine, so we are able to see all of the frames and all. So yeah, that's it. Now we have reached the end of our 3 video course where we have learned about various things in computer vision, which started from basic how to integrate and use your laptop camera for viewing yourself and analyzing the information to most important and vast case use in neural networks and all. So we have come a long way and we have learned a lot of new things. So my next and final task for you is to find various use cases where you can implement these kind of information and the knowledge which you have gained through, and you can list down at least 10 new ideas and start working on it. Thank you. Till then, take care.